A must be having order 1. Then we can apply the Cauchy's integral formula. So if the pole is having, if the pole or singular point is having order more than 1, we can go for the Cauchy's integral formula for derivative. Now you look at the equation given, that is the integration given. The singular point is z0 and it is having order n plus 1. So therefore we need to apply Cauchy's integral formula for derivative to solve the given integration. Now let us see how we are going to apply. So first of all, I am going to write the equation of the closed curve. It is given in the problem. The center of the circle is z0 and the radius is r. So we know that in complex plane, the circle equation is given by modulus of z minus a equals r, where a represents center and r represents radius. In this problem, center is given as z0 and radius is smaller. So therefore, the circle equation capital C becomes modulus of z minus z0 equals r. Now you take the given integration over c dz by z minus z0 whole power n plus 1. I have decided that the suitable formula to solve the given integration is the Cauchy's integral formula for derivative. So therefore I am going to compare the given integration with integration over c f of z dz by z minus a whole power n plus 1. And you can compare and write what is your f of z. So f of z is nothing but numerator, which is 1, and a is the z0. N plus 1 is same n plus 1. Now in the next step, I want to confirm whether z equal to z0 lies inside the given closed curve or outside the given closed curve. So to check that, we are going to substitute z value as z0 in the given closed curve capital C. That is, we are going to substitute on the left hand side of the circle equation. And after substituting z equal to z0, your left hand side of the circle equation becomes modulus of z0 minus z0, which is 0. So after substituting, you take the answer and compare with the radius of the circle given. In the question, the radius of the circle given is r and r is greater than 0. So the answer what we are getting after substituting z value is less than the radius given. So therefore I can say the particular point z equal to z0 which lies inside the given circle capital C. So therefore by Cauchy's integral formula for derivative, the answer for the given integration equals 2 pi I by n factorial into f nth derivative at the point z equals a. Now it remains to find the nth derivative of the function f, and we know that the given function f is 1. It is a constant function. So when I differentiate for the first time itself, the answer is 0. So if I differentiate for the subsequent times, again the answer is going to be 0. So therefore I can say f nth derivative at the point z is 0. So therefore f nth derivative of f at the point z equal to z0 is also 0. So therefore if I substitute all these values, my given integration becomes 2 pi I by n factorial into 0. So the answer is totally 0. So which is answer for the given integration. Coming to the seventh question, let z equals x plus iy be a complex variable. Consider that contour integration is performed along the unit circle in the anti-clockwise direction. So we are considering anti-clockwise direction as a positive direction. Which one of the following statements is not true? So we have option A, the residues of z by z square minus 1 at z equals 1 is 1 by 2. Option B, integration over c z square dz is 0. Option C, 1 by 2 pi I integration over c 1 by z dz is 1. Option D, z bar is an analytic function. The speciality of the given problem is we are going to identify the statement which is not true. We are going to identify the statement the 4 statement given in the options, we are going to identify the option which is not true. So therefore I want to check all the given 4 options. So let me check the first option. So the first option A is based on residue concept, and we are going to find residue for the function z by z square minus 1. At the z residue z equals, at the pole z equals 1. So I want to identify what is the order of the pole z equals 1 in the given function f of z. So to find the order of the pole z equals 1, I am going to equate the denominator to 0. So denominator is z square minus 1. When I equate to 0, I am getting z equals 1 and minus 1. So z equals 1 is present only one time. So it is a simple pole, or I can say z equals 1 is a pole of order 1. Now let me find out what is the residue for the pole z equals 1. So before finding the residue, let me take the function given, and we can factorize the denominator of the function given. So f of z equals z by z square minus 1. I can rewrite the denominator as z plus 1 into z minus 1. Okay, so therefore f of z is z by z plus 1 into z minus 1. So now we can write the formula for the residue. Residue of f of z at z equals 1 equals limit z approaches 1, and outside the limit we have factorial term. Since m value is 1, the factorial value becomes 1. So we have limit z approaches 1, z minus 1 power 1 into f of z, which is z into z plus 1 into z minus 1. Now z minus 1 gets cancels. So we left out with z by z plus 1. Now after applying limit, we are going to replace all the z values by 1. So therefore the numerator becomes 1, denominator becomes 1 plus 1. So therefore the answer is 1 by 2. So therefore the residue of the function f z by z square minus 1 at z equals 1 is 1 by 2. So therefore I can say the first statement, option A, is true. We are looking for statement which is not true. Coming to the second one, option B, integration over z square dz. What is the answer for the integration? Z square dz. And we know that the function inside the integration z square, it is an entire function, that is function which is analytic inside any closed curve, and of course the derivative is also continuous. You can see differentiation of z square is 2z, and 2z is a continuous function. So therefore I can appeal Cauchy's theorem. By Cauchy's theorem, if f of z is analytic inside and on the closed curve and f dash of z is continuous, so integration over c f of z dz is 0. So therefore integration over c z square dz is also equals 0. So the statement given in option B is also true. Now coming to the third statement, option C. Again it is option based on the integration. So it is given 1 by 2 pi I integration over c 1 by z dz. Now you first of all find what are the poles present for the given function f of z. So by equating denominator of the function to 0, so I have only z in the denominator, z equal to 0. So z equal to 0 is the only pole of the given function, and of course it is a simple pole. So therefore we can check whether z equal to 0 lies inside the given closed curve or not. And what is C given? So C is a closed curve given to you. So therefore we can apply the Cauchy's integral formula. So we have 1 by 2 pi I integration over c f of z dz by z minus a. Now we can compare this integration with the given integration 1 by 2 pi I integration over c 1 by z dz. By comparison, your f of z value is 1, your a value is 0. So therefore the answer for the given integration is 1 by 2 pi I is already given. So the answer for the integration is 1 by 2 pi I into 2 pi I into f of a, where a value is 0 and f of z value is 1. So f of 0 value is also 1. So therefore the answer for the integration is 1. So therefore option C is also true. So obviously our fourth option, option D, is not true. In the option D they have given z bar is an analytic function, which is not true. So we can prove f of z equals z bar is a non-analytic function using CR equation. To verify CR equation, we want to find what is the real part of the given function f of z. So we know that z is x plus iy, so z bar is x minus iy, which is conjugate of z. So therefore f of z equals x minus iy, and f of z is nothing but u plus iv. It is a complex number u plus iv, which is equated to x minus iy. When I equate real part on both sides, I will get u value as x. When I equate imaginary part on both sides, I will get a v value as minus y. Now you find out u suffix x, which is 1, u suffix y, which is 0, v suffix x, differentiation of v with respect to x, there is no x term, answer is 0. V suffix y, differentiation of v with respect to y partially, so minus y becomes minus 1. Now we can easily see ux is not equals vy, because ux is 1, vy is minus 1. For any z value, they are not going to be equal. So therefore the CR equations are not satisfied even for a single point. So therefore f of z equals z bar is not analytic. But in the option D, it is given z bar is an analytic function. So therefore the statement D is not true, which is the required answer. Coming to the 8th problem, the value of the integration 1 by 2 pi j integration over c e power z by z minus 2 into dz along a closed contour capital C in anti-clockwise direction for first point, the point z0 equals to inside the contour capital C, and the second one, the point z0 equals to lies outside the contour capital C respectively are option A 2.72 and 0, option B 7.39 and 0, option C 0 and 2.72, option D 0 and 7.39. Multiple choice question carries 1 mark. So in this question, we have to work out the integration for 2 different cases. In the first case, we are going to consider z0 is a point, it is a pole lies inside C, and we are going to find answer for the given integration. And in the second case, we are going to consider z0 equals to lies outside the contour, and what will be the answer for the integration given. One thing is very clear, by looking the integration, the only singular point is z0 equals 2. So if that point lies outside, the answer for the integration will be 0. Because if I say the singular point lies outside C, so I can say the function given inside the integration is analytic function. So therefore by Cauchy's integral theorem, answer for the integration is 0. So for the second case, the answer is 0. By looking at the options roughly, in option C and D, the second case answer is non-zero, which is not at all correct. So therefore, any one of the option A and B is going to be correct. Now to confirm, we are going for the first case. That is, we are going to consider z0 equals to lies inside the contour C. So first of all, we are going to check what is the order of the pole z0 equals to. So for the given integration, z0 equals 2 is a pole of order 1, because that is the only factor. Z minus 2 is the only factor which is present in the denominator. So therefore it is a pole of order 1, or I can say simple pole. So, and it is given in the condition the pole lies inside the contour C. So therefore we are going to apply Cauchy's integral formula. So therefore I am going to consider the given integration. We are going to compare the given integration with Cauchy's integral formula.